Yesterday we learned that a ratio is a comparison between two different quantities. Today we're going to learn about rates, unit rates, and a rate is a ratio of two quantities that are measured in different units. So we're going to go ahead and write down the definition. It is a ratio of two quantities measured in different units. Go ahead and underline the word different units, because that's the key to a rate. We're going to see that we're comparing things that are totally different, unlike what we were doing yesterday. Let's look at an example. Let's say you are measuring your growth over time, and you have been growing 2 inches in the last 4 years. I've written this as a ratio in fraction form. I could also write this as 2 inches in 4 years. And I can also use the word per. 2 inches per 4 years. Per, just like when we use the word miles per hour, it means to divide by. It means we are working with a rate. So these are all examples of rates because the units of the numerator are different from the units of the denominator. We've got inches and years, whereas yesterday's ratios were the same units. All right, so next thing we need to learn about is what a unit rate is. A unit rate, very simply, has a denominator of 1, hence the word unit. Now when you're comparing rates, it's much more simple to compare rates that have a common denominator, just like when we were comparing fractions in a previous unit. When you compare fractions, you find a least common denominator, set them equal to each other, then you can just compare the numerators. It's the same exact idea when we're using unit rates. If you go driving, and one person says, oh, well, I drove 45 miles per hour, that's a unit rate. It's 45 miles in 1 hour. However, if somebody else told you that, yeah, well, I drove 80 miles in 2.5 hours, now all of a sudden we can't compare those directly. We have to do some math before we can compare them. And so unit rates help us to compare things directly. Let's see how we can do that with this first rate. We said it was 2 inches in 4 years. So what I usually do is I write my units off to the side to keep track of them. And then I'm going to write my 2 inches over 4 years. If I want to have a 1 in the denominator, we need to divide the 4 by a 4. But I can't change the value of this fraction, so I need to also divide the numerator by 4. Just like when we found equivalent fractions, this is really just dividing by a factor of 1. 4 divided by 4 is 1. So I haven't changed the value of my ratio here, but what I have done is rewritten it so that the denominator is only 1 year. 2 divided by 4 is a half, or 0.5. So I would say that the unit rate of my growth here is 1/2 inch per year. And again, when we're talking about rates, this fraction bar, we can just use the word per. So 1/2 inch per year is the unit rate. You might also write 1/2 inch in a year. When we use the word in, that also indicates a rate. Okay. Let's look at a couple additional ones. For example, B. Let's say you have made $3,000 in 2 months. We'll use MOS as an abbreviation for months. Okay. Now this time, instead of writing the fraction, I am going to write what units I have in the numerator and the denominator just to keep them straight. I have 3,000 over 2. Now this time, instead of dividing by 2 over 2, which is exactly what we're going to do to get a denominator of 1, I'm going to show you a shortcut. The shortcut is basically take your numerator, divide it by the denominator, and put it over 1. So 3,000 over 2 is 1,500. That's $1,500 for every 1 month, or $1,500 per month. Notice that up here, since the denominators are divided by itself, it's always going to be 1. So really the only thing we have to worry about is numerator divided by, and where does this number come from? Well, it's whatever the denominator was. So you just take the numerator divided by denominator, that's your unit rate. 2 over 4 is a half an inch in a year. 3,000 divided by 2 is 1,500. $1,500 in 1 month. Sometimes you're going to get a ratio where you have more than one unit in a term. So for example, let's say we're running a race and we travel 1,500 meters in 2 minutes 30 seconds. Now when you first look at this, you might say, well, this seems like there's 3 units. We've got meters, minutes, seconds. But really we just have to look at what we're measuring. Here we're measuring distance. Here we're measuring time. So we have 2 different units here. Units of distance, units of time. So I'm going to rewrite my ratio, 1,500 meters in, but now I have to make a decision. I either have to express this amount of time in minutes or in seconds. It can't be a combination of both. Diego, how many seconds in a minute?
60.
60 seconds in a minute. So how many seconds in 2 minutes?
120.
120. Plus the 30 additional seconds?
150.
150 seconds. So I can say this is 1,500 meters in 150 seconds. That's one way that I can express this, this rate. Now it's not quite in a unit rate because I need to divide my numerator by my denominator. In this case the math is pretty easy because it is 1,500 is simply 10 times bigger than 150. So 1,500 over 150 is then 10 meters per second. That would be the unit rate. My denominator now is 1 second. We're running 10 meters in 1 second. Now you also could have gone another way with this. You could have written your ratio as a distance over time in minutes. Diego, how much of a minute is 30 seconds? What fraction of a minute is 30 seconds? There's 60 seconds in a minute.
Yeah.
So
you would have to add another 30 seconds.
Right. So it's a half of a minute, right?
Yeah.
So this is 2.5 minutes. So I could write this unit rate this way: 1,500 divided by 2.5, and that would be in meters per minute. Now this isn't yet a unit rate. So let's do my division over off to the side here. 1,500 divided by 2.5. Move the decimal place 1 over. And now I have 15,000 divided by 25. So 25 does not go into 1 or 15, but it goes into 150 6 times. And it goes in evenly. And I bring down a 0. Bring down another 0. And I get 600. So in this case, I get 600 meters per minute. Now, if I've done this correctly, I would expect that the rate per minute, the distance you cover per minute, should be 60 times what you can cover in a second. And sure enough, 10 times 60 is 600. These are totally equivalent in terms of unit rates, and they're both equally valid unit rates. So you can see we can go either way. We could have changed it into seconds, or we could change the time into minutes. The main thing is you cannot have more than one unit of time or unit of anything in the denominator or in the numerator. Does that make sense? Okay. Now let's look at an applied problem of using unit rates. This is where you're going to use this the most often. As a consumer, you need to figure out what is a better deal. So these types of problems, which is a better deal, are one of the most commonly found unit rate type problems. And the idea is when you go grocery shopping, for example, You might look at one product, a box of cereal, and there's a really big box for a certain price, and then there's a small box for a lesser price. But in order to figure out which is a better deal, we have to be able to turn them both into unit rates so that we can compare them directly. Okay. So let's use as an example. Let's say we're buying some dried fruit, and we could buy it in bulk in a big bag, $15 for 10 pounds. If you're not familiar with it, LBS, the letters LBS, are a common abbreviation for pounds. Okay, so option 1, $15 for a 10-pound bag. Option 2 is I can buy them in packages individually. They only cost $3.98 for 2-pound packages. So those are my two options with buying the dried fruit. And then the question is, which one of these options is a better deal? And how much of a better deal is it? So let's start by changing them both into unit rates. Because we can see that, if the smaller package cost more, we would know, of course, that it was not a better deal. But in this case, the smaller package does cost less. The bigger package costs more. So it's not immediately obvious which one is a better deal. And this is measured in 2 pounds, and this is measured in 10-pound bags, so we can't compare them directly. So we're going to get them a common denominator of 1 so that we can compare them directly. So let's start with the bulk package. Okay, usually, we're going to do dollars per pound. So I'm going to write my units off to the side so I can keep track of them. I've got $15 for 10 pounds. Now remember, when we find a unit rate, all I have to do is divide the numerator by the denominator. 15 over 10 is 1.5. So that's $1.5 or $1.50 for every 1 pound, or $1.50 per pound. That's my bulk price. Then I'll look at my packages. I'm going to do the same thing. Compare dollars per pound. And I get $3.98 for 2 pounds. I'm going to do my division over here quickly. 2 goes into 3 once. Product of 2, difference of 1. Bring down the 9. 2 goes into 19. 9 times. Product of 18, difference of 1, bring down the 8, 2 goes into 18 9 times, bring the decimal straight up, and we find that we are spending $1.99 for every 1 pound, or $1.99 per pound. Okay. So we can see now that the bulk package is a much better deal than the smaller packages. This only costs us $1.50 per pound, and this costs us $1.99 per pound. And obviously, we want to spend less money for the same thing, right? Unit rates also work the other way, though. In fact, so you might think of this as in how many pounds do I get for $1? So let's set it up that way and see if we get the same answer. So pounds on the top, dollars on the bottom. We want to find out how many pounds you can get for $1. Okay. So in this case, you get 10 pounds for $15. That's 10 over 15. That simplifies to 2/3, which we should know is, as a decimal, is 0.66 repeating. Right? So that is 67 cents, or $0.67, or pounds, I'm sorry, 0.67 pounds for every $1. Okay, so we get 0.67 pounds per dollar. If you don't remember what 2/3 was as a decimal, you could always divide 2 by 3. It doesn't fit, so you put it here, 18, difference of 2, 20, and you can see that it repeats. Okay. So in this case, the bulk, you get 0.67 pounds per dollar. Let's see how it works out with the packages. So we get pounds and dollars. So in this case, 2 pounds for $3.98. All right. This division is a little less convenient, but we'll go do it over on the side here. 2 divided by 398. I need to bring the decimal point 2 places over. So this becomes 200. 398 does not go into 200. So we add another 0 and a decimal. 398 goes into 2,000 5 times. I'm going to do the multiplication down here really quick. 40, 45, 9, 15, 19, 90. Okay, so a difference of 10. Does not fit in there, so I add a 0, and a 0, another 0, and this fits into 1,000 twice, and we've gone far enough with our decimal here to figure out which is a better deal. So in this case, you get 0.5 pounds for your $1. Now, in our first example, we wanted a lower number. A lower unit rate would tell us it was a better deal because I'm spending less money for the same thing, right? However, down here, we want a bigger number because we are getting more product for our $1. Okay? You only get half a pound of product for your $1, and here you get 2/3 of a pound of product for your $1. So no matter which way you set up this unit rate problem, your answer is still going to be the same. What you need to keep track of is depending on how you set up this ratio, you might want the smaller number or you might want the bigger number. So I always suggest say it out loud, or at least in your head. Say, all right, this is 2/3 of a pound for my $1. This is half a pound for my $1. I want more for my $1. This is my better deal. And like we might usually expect, bulk is often our better deal. And that's the reason that it's sold in bulk and why people buy in bulk packaging. Your homework tonight is to complete these 3 problems. They are saved in a PDF on the web as well, and we will go over them tomorrow. Again, please do them on your own without assistance so that we can use it as a self-assessment tool in the morning.
Bye.